To begin taking apart the cell phone, we started by unscrewing the screws that connected the iPhone back to the frame of the cell phone. We then used a screwdriver to pry the front glass off of the interior of the phone. We originally attempted to take off the plastic backing from the body of the phone, but then we realized that there was hardware attached to the plastic backing. This hardware prevented us from prying the plastic backing off of the body of the phone. So, we decided to try taking the screen off instead, which was a better approach. We then detached the 3 ribbons connecting the screen to the body so we could fully remove the screen from our phone. Next, we took the SIM card out from the back of the phone. We did this by using our fingers to push the SIM card out of its holder. Our next step was to separate the LCD from the screen. In order to do this, we found there were 6 screws to be removed that secured the LCD to the assembly. We again used our screwdriver to remove these screws, then pulled apart the LCD from the touchscreen using a thin plastic wedge in between to pry open the parts. We shifted our focus back to the body of the phone. We wanted to remove the motherboard to have a better look at it, since the circuit board is a significant contributor to the functioning of the phone. In order to do this, we needed to disconnect multiple connections, which fortunately were labeled clearly in number order. We first removed the connection labeled 4, then the ones labeled 5, 6, and 7. However, that was not it, as there were 8 small screws that secured the motherboard into the case of the iPhone. We unscrewed these so we were able to fully remove the motherboard. We realized that the camera was directly connected to the motherboard, so we extracted that. Our next focus was the bottom portion of the phone, specifically the dock port assembly. We removed the 3 screws that connected it to the iPhone 3GS. Then, with the screws removed, we were able to detach the assembly from the iPhone. With this out, we were able to approach the battery. With no visible screws or connections, we attempted to simply pry the battery out of the iPhone case. However, we had difficulty in doing so we decided to use one of our tools to wedge under it. After much effort, the battery peeled up, making the noise that a sticker does when you peel it off. This made us think that over time, the glue that adheres the battery to the phone must melt and reharden due to the heating up and cooling down of the iPhone when it is used. Having removed the battery, we located the assembly at the top of the iPhone. We took out a series of screws so we could then remove the power button, volume button, and the headphone jack, which we then realized were all connected. We had to be careful to not break or rip the ribbons that connected the different aspects, but with patience, we were able to successfully remove them. The last piece remaining in the body of the iPhone was a small contraption that, with research, we figured out was the vibrator motor. This motor is what makes your phone vibrate to alert you when you receive a call or when an alarm goes off. We were easily able to remove it from the body of the phone simply by unscrewing the remaining 2 screws. With the separated pieces of the phone laid out, we were able to look more closely at certain specific elements. We chose to research how the touchscreen, circuit board, and battery function in depth, as these parts of the phone interested us the most. Apple did not invent the first touchscreen. The credit goes to E.A. Johnson in 1965, but Apple did make some impressive innovations to the design. Apple decided to use a capacitive material which allows the iPhones to detect touch based on a change in the amount of electrical charge where you touch the screen. However, you must use your fingers to do so since they conduct electricity. This is why you can't use the touchscreen on your iPhone when you wear gloves. The gloves block the electrical signals from your fingers to the capacitive screen. You would need touchscreen gloves, which work because the fingerprints are sewn with conductive wire. This allows the electrical current from your fingers to pass through the glove, making the touchscreen responsive. The original touchscreen was only sensitive to a single touch, whereas Apple integrated the touchscreens with a coordinate system, letting users touch the screen in multiple places at once to get different results to happen. For example, you can use 2 fingers and drag them apart to zoom in. Now, with the latest iPhone designs, they even have 3D touch, which can detect the amount of pressure with which one presses on the screen. Who knows what touchscreen innovations hold for the future iPhone design?
All of this is possible due to the microprocessor located in the circuit board of the iPhone. This small but mighty processor is the heart of the iPhone. Without it, the phone could not function. On a basic level, a microprocessor can calculate mathematical equations, move data to memory storage or retrieve it, and make decisions about instructions. The more transistors that a processor has, the faster it can perform operations. Transistors control the flow of electrical current, operating in a binary state of ones and zeros. This current is used in combination with algebra that has been programmed into the processor, allowing the device to make calculations at an extremely fast speed. However, one problem with these transistors is that they create wasted heat, making the device less efficient. The solution is in molecular transistors. These transistors can be made from a single molecule along with some atoms, which is so precise that it can control the individual electrons within a current and allow for efficiency like we've never seen before. The battery that is used for the iPhone 3GS is a rechargeable lithium-ion battery. This type of battery is found in most phones, laptops, and iPods, and is still being used in iPhones today. Again, the credit does not go to Apple for the invention of these batteries. It was John Goodenough who deserves the credit in 1922. These batteries are most popular because of their high energy capacities and their small and lightweight design. The electrodes of a lithium-ion battery are made of lithium and carbon. Lithium is a highly reactive element, which allows for a lot of energy to be stored in its atomic bonds. With a high energy storage for a small weight, these batteries are considered to have a very high energy density. These batteries are also very popular as they have no memory effect, meaning they don't have to completely discharge before recharging. For example, you can begin charging your phone again even if it is at 70% charge and not all the way at 0%. However, these batteries are not perfect. They will only last about 2 to 3 years from the date of manufacture. They are also extremely sensitive to high temperatures, causing them to degrade much faster in the heat. Although lithium-ion batteries come in different shapes and sizes, they are all quite similar on the inside. The lithium-ion cells can be either cylindrical batteries that look like AA cells, or they can be prismatic, which means they are square or rectangular in shape. In the iPhone 3GS that we disassembled, the battery was prismatic. These batteries also require a tiny computer that contains temperature sensors to monitor battery temperature, a voltage converter and regulator circuit to keep levels of voltage and current in the proper range, a shielded notebook connector which lets information and power flow in and out of the battery, a voltage tap that monitors the energy capacity of individual cells, and finally, a monitor for how much charge the battery has. The chemistry behind lithium-ion batteries is quite complex, but in simple terms, it is about electron and ion flow. While charging the battery, ions, which are electrically charged particles due to the loss or gain of electrons, move from the cathode, which in this case is lithium, to the anode, which is carbon, by way of the electrolyte between them. This energy is stored in the carbon anode for use. When you go to use the iPhone, the ions return to the cathode, producing energy. Electrons always flow in the opposite direction of the ions and cannot cross the electrolyte barrier. Instead, they take a path through the outer circuit, which is made of wire.
While we were reverse engineering the phone, one of the first things we took off of the phone was the glass that serves as the front of the phone screen. We all commented about how different this glass looks in comparison to our current iPhones. This piece of glass was made up of a form of Gorilla Glass. Gorilla Glass is a strengthened form of glass that is meant to withstand falls and scratches. Gorilla Glass has since been upgraded several times, meaning that the Gorilla Glass used on more recent iPhones is even more resistant to scratches and cracking than older versions. We performed our own scratch test on the Gorilla Glass. We first attempted to scratch the glass with graphite found in a mechanical pencil. However, we were unsuccessful. We then attempted to use a plastic wedge to scratch the glass. Once again, we were unsuccessful. Our next attempt was to use a metal screwdriver to scratch the glass. We were still unable to scratch the glass. Our final attempt was to use a pair of metal scissors to scratch the glass. Despite our best efforts, we were still unsuccessful. This told us that the Gorilla Glass used on the iPhone 3GS is scratch resistant. The back of the iPhone 3GS is made up of a plastic backing. After reverse engineering the phone, we were able to see that the backing held all of the phone's components together. After removing all components from the phone, we noticed that the plastic felt fairly flimsy. We were able to bend it quite easily. Upon research, we were able to discover that this plastic backing was not normal plastic. It is actually a specially designed plastic made by Apple. While Apple has not confirmed the exact composition of the backing, it is believed it is made out of zirconium and yttrium mixture that is then coated in plastic. Apple has a patent on this zirconium and yttrium mixture. The inside mixture would give the backing stability and durability, and the plastic coating would provide a protective barrier for this inside mixture.
As we took apart and examined the iPhone, we noticed a lot of changes that we could make to improve the design. One design flaw we noticed was the plastic backing of the iPhone 3GS. With it removed from the iPhone, we realized how flimsy it was. We thought to ourselves that it was not a very protective backing for such an expensive device. Using metal would make the phone harder, and thus more difficult to break. This may make the iPhone slightly heavier, but we think that the more protective backing would be worth it for the longevity of the phone. Another issue we noticed when taking apart this old iPhone was that there was a lot of dirt that had gotten into the hardware. We assumed that this happened due to the holes for the charger, headphones, and gaps between the volume and home buttons. These holes can let both dirt and water in, which allows for corrosion. To address this problem, you could completely get rid of the actual physical buttons in replace of a pressure sensor where the buttons usually go. The buttons would be etched or drawn on, so one could see where they are. You could then press where the buttons are without having any holes for dirt or water to enter. As for the headphone and charging ports, you could have wireless music and perhaps a stand that you could set your phone on to charge it. This would completely eliminate the need for a headphone and charging port. In making the phone keep out dirt and water to prevent corrosion, we also created a waterproof phone. This would definitely improve sales, since people would be able to take pictures underwater and not worry about ruining their phone by accidentally dropping it in water.
We reverse engineered an iPhone 3GS. This was the third iPhone model that Apple released. Since the release of the iPhone 3GS, Apple has released an additional 11 new iPhones. With each new iPhone comes improved camera quality, durability, faster processing speeds, and increased storage. The iPhone 3GS we reverse engineered had a maximum storage capacity of 36 gigabytes, whereas the current iPhone X models have 256 gigabytes of storage. The cameras on the iPhone have also drastically improved. They have added many additional features since the iPhone 3GS was made, including slow-motion video, panorama photos, and portrait photos. Features have also been added like FaceTime, a fingerprint unlock scanner, and a Face ID scanner. One additional change is that the iPhone screens have gotten larger, while the phones themselves have gotten slimmer. They have even created a plus-size version of newer iPhone models. The plus-size versions are equipped with larger screens as well as longer battery life. Even with all of the improvements Apple has made upon the iPhone 3GS, there are still many ways that the iPhone can be further improved. For instance, the screens are still able to shatter if the iPhone drops, and the batteries wear down as the phone gets older, eventually becoming virtually unusable. Even with the faults iPhones face, it seems as if there is no end coming to the Apple iPhone monopoly. Apple continues to release cutting-edge technology that constantly beats out competitors.